Hello, everybody. I hope things are going well for you. And this is lesson 17 in Math 100. Lesson 17 start a new chapter, and this is chapter 7.1 and 7.2. Today's topics are sort of twofold, although they are connected to each other. So the first topic we'll be talking about is mathematics and art. What does math have to do with art? And the answer is it's quite a bit, all right? And then we'll be talking about the Fibonacci sequence and how that is related to art. But first, we'll talk about the historical significance of perspective, which is a part of geometric property or projective geometry. All right, so let's study math and art. All right. So lesson 17 is on these two sections, math and art, perspective, Fibonacci sequence, and the golden ratio, which is closely related to the Fibonacci sequence. So the question I want to begin with is the one that I just posed already. What does mathematics have to do with art? And the answer is actually quite a bit, okay? And so let's, and I will be showing and sharing some PowerPoint slides to illustrate these points. But let me explain first what's going on and what I will be talking about, right? So a key to drawing three-dimensional objects on canvas, and this is something that really every artist since the time of Renaissance has practiced, and that is to draw three-dimensional objects, you know, because basically art, especially when you draw or illustrate or paint, is going to be on a two-dimensional plane, typically called a canvas, okay? Not canvas as in our course management system, but on a piece of surface called canvas, all right? And so the key is this whole idea of perspective. All right, and as I just sort of hinted at this, it is actually a part of what, or the at least the properties come from our discipline, mathematics, in particular, projective geometry. All right, and I'll explain what that means in just a moment, okay? But as I said, this really began in the Renaissance. And you can study the history of art, and I'm sure after the Dark Ages, you'll go into the Renaissance period. And places like Florence, Italy, there's a reason, and maybe you can study in history why Florence played a key role in the birth of Renaissance. Basically, it has to do with money. Okay, you may have heard of a family, a pretty wealthy family called the Medicis, and because the Medicis held the money, basically the bank account for the Pope. They were pretty wealthy people, and they were able to commission a bunch of artists. It's like an artist's dream, right? I mean, you were just given so much money to do your artistic work, and that's how the Renaissance art flourished, and that's why it happened in Italy, especially in the area today known as Tuscany. That is where Florence is. Okay, so let's talk about the principles of perspective. What are we talking about here, right? And by the way, you may wonder, why do we have to do art? You know, this is a math class, right? Remember, this class, Math 100, is called Math for Liberal Arts or Liberal Arts Mathematics, all right? So we study humanities, we study art. Next time we'll talk about music. And we have already talked about, you know, math and finance and the math and this and math and that. We'll also talk about mathematics and politics. So there are lots of areas in which surprisingly mathematics play a very, very important role. Art is no exception. Okay, an actual object. So this, okay, let me explain what's happening here. An actual object in the world, in the three-dimensional world, is drawn by what we call a visual pyramid. Okay, so you may have heard about these things. Right, so you see a pyramid here. Here's your eye, okay? I, by the way, am no artist, even though I'm talking about an art today. All right, so here's your eye. And what you see is here's, you know, the apex of the pyramid. And the object is actually, you know, like here, maybe let's draw a little trash can or something like that, right? So you have a typical trash can, all right? And you have a lid, and this is your trash can. Now, how would you draw that on this piece of paper or a piece of cloth, whatever, it's canvas, right? And so the apex, of course, that's the vertex here, is the eye, right? And all, okay, so let me, maybe I should illustrate what's happening here. What happens is, on the canvas, you are supposed to draw this thing, right? And so here, let me go ahead and draw another, maybe a slightly thin lines, or a couple of lines. And I think you will get the point here. Maybe very thin lines. Okay, so oh, that's not the right. No wonder. Okay, see, I'm going to draw maybe with the dotted lines, and I will change the colors here. The place where the top of the trash can goes to will be the intersection of this line I just drew and the canvas. All right. And so basically, this is all that's going to happen. And everything that you will be, so basically the trash can gets projected onto this canvas at the point where these lines, okay, let me make it a little thicker here, intersect the canvas, right? So on this canvas, the image of the trash can will be something like this, all right? And if you look at this from the perspective of the eye, from where the standpoint, if you move the standpoint to where the eye is, it's pretty much going to look like this, all right? So this is, these couple of pictures here illustrate what's happening with this. All right, so all parallel lines parallel to the canvas, okay, all lines parallel to the canvas will remain parallel on the canvas. So what am I talking about? All right, so imagine you have this type of a box here, right? So these, okay, so notice here, all of these, maybe I should draw in a different color here, right? All parallel lines parallel to the canvas. So these are lines like this, okay? Notice here, these are actually lines that are on a parallel plane to the canvas, right? And so these, okay, that's not a line, but okay, all of these are lines parallel to the canvas. And if they are parallel, like this one and this one, okay, they will remain parallel to each other, all right, even in the painting or even in the drawing. Okay, that's what this means. And maybe I should focus on the parallel lines here. Okay, but anyway, and then let's draw into here. Orange. Actual parallel lines perpendicular to the canvas will merge at a principal vanishing point. So now, if you have been drawing or if you're taking an art class, these are like maybe some of the most basic principles, and you may have been practicing this for a long time. I've had some incredible art students in this class in the past, and that were very, very good at drawing these pictures, right? And some of them are almost like a professional level. So what does it mean? Well, so these are the ones I'm talking about here. See this line here, this line, these are all lines parallel to each other in the real world, but they're all perpendicular to the canvas on which I'm drawing this, okay? Same thing here, this line, this line, this line. All of these lines are actually parallel in the world, in the three-dimensional world, right? And in fact, this and this, all of these are lines parallel in real life, but they're all perpendicular to the canvas or the plane on which I am drawing. And they will all meet at a principal vanishing point. And so there is your principal vanishing point. Sometimes it's called the VP for vanishing point. Sometimes people add P to stand to represent the principal vanishing point, right? And so if you track these, if you extend these lines here, they all meet, all of these will meet at one particular point, and that is a point called a principal, the point called the principal vanishing point. Okay, now all other parallel lines merge at some point on the HL or IL, EL. So when you say HL, it's the horizon line. EL, sometimes called is referring to the eye level, okay? And that's pretty much the same thing. All right, and so these are the things I will be illustrating this in just a moment, okay? A classic example of this, you have a famous piece called the Last Supper. Okay, you are familiar with that. I think the original piece is now in where? Somewhere in Italy, probably Milan, right? By Da Vinci, Leonardo da Vinci, right? And I'll be mentioning this in just a moment. A modern artist playing with this. Okay, so we have interesting drawings by people like Maurice Escher, and here's a artist who incorporated lots of mathematics in his drawings and paintings, even though he himself was really not aware of the mathematical principles he was using. Once upon a time, Escher was given a lecture by a mathematician, and he had no idea of what was being discussed, even though his drawings and his paintings were the basis of the lecture. So, all right, and then later I'll be showing you some work by a man named Julian Beever. Okay, now Julian Beever is a contemporary. He is still quite active as far as I know, and he's a chalk artist. He draws different things on streets and on sidewalks and so on, right? And so I think you will find this quite interesting, and it's sort of shocking how he makes things look real, even though he's drawing things on a street, on a flat street. And this is where he is standing here, you know, and so on. Okay, so let me show you what I'm talking about by sharing some PowerPoint slide. Okay, so in this next part coming up, I'll be showing you some slides to illustrate what I was talking about, and I hope you will enjoy some of these interesting slides. Okay, so here we go, part 2.